This is the video for your notes on 6.2, or fractions, decimals, and percents. It covers pages 21 through 32 in your notebooks. You'll need 1 pencil and 6 colors, preferably red, orange, yellow, green, blue, and purple, highlighters, or colored pencils. A comparison of any two quantities or amounts. It can be written in 3 different ways, but the order of the amounts or quantities stay the same. I could write if I'm comparing diamonds to circles, I could write 4 diamonds to 10 circles, or I could compare the 4 diamonds to the 14 total shapes. I can write this with the word 2, with a colon, or as a fraction, and this is a ratio. Now, a number that is written with a numerator, or the part, and the denominator, the whole, and the line separating the numerator and denominator represents division. So I have 3 as my numerator, 5 is my denominator, and this division sign or fraction bar is the division sign. So this is an example of a fraction. Now a ratio can be written in the form of a fraction. So if I want to write a ratio as a different form, I might need to write it as a fraction and then convert it. So a number that's written in our place value system, which is based on the number 10, I can have 2 wholes, I can have 4 tenths, and 3/100ths of a square. So I'd have 2 in the ones place, 4 in the tenths place, and 3 in the hundredths place. This is an example of a decimal. Now I can write a ratio as a fraction and then convert it to a decimal using division. A number that represents how many parts out of 100. So here I have 100, and I have 10, 20, 30, 40, 50, 66 of those shaded in. So 66 out of 100 would give me 66%. So if you are looking at percent, the suffix cent, or the root word cent, is very important. So per means for each. So if I hand out 1 paper per student, there's 1 paper for each of the students. And cent literally means 100. So for each 100, how many out of those 100? That will give you the percent. So to change a number from one form to an equivalent number or equal number in a different form. So if I change 3 tenths, I do 3 divided by 10 to get 0.3. And that's how I would convert it to a decimal. And if I move the decimal place 2 times to the right, then I would convert that to a percent. So if you're changing or moving between fractions, decimals, and percents to a different form, you are converting. So to order numbers from smallest to biggest amount, so you start small and it gets bigger and bigger, there's a few different vocabulary words that mean the same thing, or synonyms. So this is when we're getting larger or bigger. We could have least to greatest, ascending is another word, or increasing. Now to order numbers from biggest to smallest, they're getting smaller in size. The numbers are getting smaller in size. We could write greatest to least. We could write descending, or we could write decreasing. All 3 of these mean the same thing. When working with decimal numbers, we need to understand what each number means. This will help us when converting between decimals and fractions. So if I have 4 groups of 100, or hundreds, 7 groups of 10, or tens, 2 groups of 1, or ones, and, that's the decimal, 6 tenths or part of 1 whole, that's tenths place, 1 100ths of 1 whole, it's the hundredths place, and 5 thousandths of 1 whole, then that's going to be the thousandths place. Now, each of these will go in the place value. So 4 would go in the hundreds, 7 would go in the tens, 2 would go in the ones, 6 would go in the tenths, 1 would go in the hundredths, and 5 would go in the thousands. So let's kind of look down here and grab our highlighters. You can look at the decimal, and that's where we say and in our name. So I would say this is 472 and 615 thousandths, because the last place value on the decimal side is the thousandths. So the hundredths place has a 4. The tens place has a 7. If we're looking at the ones place, there is a 2. And this tells us the value. Now, we have the tenths place. We could put a 1 underneath the decimal, and we have a 6 in the tenths place. We have 2 decimal places over, would give you the hundredths place, and we have a 1 in the hundredths place. And if we have 3 decimal places over, that we have a 5 in the thousandths place. Now, if you want to write a ratio of the shaded pieces to total pieces, and convert this ratio to a decimal, a fraction, and percent. So shaded to total is the ratio that we are going to write. So I count that. I have 1, 2, 3, 4, 5, 6, 7. I have 7 shaded pieces to the 10 total pieces. Now I would write the first number stays first, and the second number is second. So we have 7 tenths, and 7 in the tenths place. Well, I would just write the 7 in the tenths place, and we get 0.7. Now 0.7 looks like 70 cents, and 70 cents would look like 70%. So I would move that 2 decimal places over to the right to show that we are going to get 70%. Now for this next one, we're going to write the number of shaded pieces to total pieces. So we have 10, 20, 30, 7, and we're comparing that to the total number of pieces. So 37 shaded pieces and 100 total pieces. So 37 is the first number and 100 is the second number. And for a fraction, we are going to write the first number as my numerator and the second number as my denominator. Now for the decimal, I have a place value called the hundredths place, and that's 2 decimal places out. So I have the tenths place and the hundredths place. I'm going to put 37, so the last number is in the hundredths place. So we see that our decimal is 0.37. Now to change this into a percent, 37 cents is going to look like 37%. And we move the decimal place 2 places to the right. It jumped over 2 numbers. Again, we want to write the number of shaded pieces to our total number of pieces. So I see that I have 3 shaded pieces, so that's our first number, compared to the 5 total pieces. So my first number is 3, so that's going to be my numerator, and my second number is 5, so that's my denominator. I know if I multiply the numerator and denominator by 2, then I would end up being able to get 6 tenths. Now I can put a 6 in the tenths place because I have a tenths place value. I can't just go 0.3 because I don't have a fifths place value. And 60 cents looks like 60%. And you could also remember that each of these is worth 20%. So 20, 40, 60, we see that that's 60% shaded. Now write the ratio of shaded pieces, 5, to total pieces, 4, 5, 6, 7, 8. So 5 to 8. Now the fraction, we have the first number is 5 and the second number is 8. So we have 5/8 is shaded, and we want to divide that. And 8 goes into 5 0 times, but 8 goes into 50 6 times. And 6 times 8 is 48, with 2 left over, and we bring down the next 0. And 8 goes into 22 times. 2 times 8 is 16, with 4 left over. And 8 goes into 40, 5 times with 0 left over. So our decimal is 625 thousandths. And that kind of looks like 62 cents with some left over, so that should look about like 62%. So we're going to move the decimal place 2 times to the right, and we get 62.2%. 0.5%. Given the following ratio of shaded pieces to total pieces, complete the table and shade the figure appropriately. So I have 0.8, and I know that that is called 8/10. So 8/10, I could write that as a fraction and simplify, dividing the top and bottom by 2, and I'll get 4/5. So my simplified fraction is 4/5. And that means that I have 4 shaded compared to 5 total. So I'm going to shade in 4 of the 5. Now the ratio, the first number is 4 and the second number is 5 in the fraction, so that's going to be the same in our ratio. For the percent, that looks like 80 cents, and I'm going to move it 2 places to the right, so 80 cents would look like 80%. Given the following ratio of shaded pieces to total pieces, complete the table and shade the figure in appropriately. So my fraction is 9/20. So if I take 9/20 and I write that as a ratio, I want to compare the total out of 100. So 20 times 5 gives me 100, and that's going to be my total. I need to figure out how many are shaded because I'm comparing shaded to total. So I multiply the top by 5 as well to get 45. And I see that I'm going to have 45 shaded. So I'm going to color in 40 of these, 4 columns of 10, and then I'm going to shade in 5 more. Now I have 45 shaded to 100 total, and that's the same ratio as 9/20. Now I have 45 out of 100, so if I have my hundredths place, 45, the 5 or the last number will end up in the hundredths place. And 45 cents, moving the decimal place 2 times to the right, would give us 45%. Now we're going to show you how to go from a fraction to a decimal. Now to go from a fraction to a decimal, you take the first number and divide by the second number. The order really matters, and sometimes the smaller numbers first. So we rewrite an equivalent fraction with a denominator of 10, 100, or 1000, and this is the easier method rather than doing division. So if I multiply 2 and 5 by 2, I end up getting 4/10. Now 4/10, all I have to do is look at the tenths place and put that 4 into the tenths place. And now 2/5 is equal to 0.4. I could show us how to do 2 divided by 5, and this method will always work. So 5 goes into 2 0 times, and 5 goes into 24 times with 0 left over, so we see 2/5 is equal to 0.4, but there's multiple ways to get to that answer. For 6/25, I can figure out, well, 25 times 4 would give me 100, and 6 times 4 would give me 24. So 24 100ths works very well because I could put the 24 with the last digit in the hundredths place. So 0.24 is my decimal. For 3/20, I know 20 times 5 would give me 100. So I can multiply the numerator by 5 to get 15 hundredths, which means 15 with the 5 will end up in the hundredths place. So if it was 5 hundredths, we would write 0.5 and make sure that that last number always ends up in the hundredths place. 7/8 is a little bit more difficult, but if you want to use this method, 8 times 125 is 1,000, and 7 times 125 is going to end up giving us 875. So if I have 875 thousandths, I can go out to the thousandths place, and the 5, or the last number, will end up in the thousandths place. So we get 0.875, or 875 thousandths. Eighths are kind of hard, and multiplying by 125 is not the easiest. So I'm going to use division. Division will always work, and we could do 3 divided by 8. So I'm going to write 3 like $3, and bring the decimal up. 8 goes into 3 0 times, 8 goes into 30 3 times. 3 times 8 is 24, with 6 left over. And we bring down the 0. And 8 goes into 60 7 times. 7 times 8 is 56, with 4 left over. And bring down the 0. 8 goes into 40 5 times, with 0 left over. So our final answer is 375 thousandths, or 0.375. 2/3, I can't multiply 3 by anything to get 10, 100, or 1,000, so I have to do division. Unless I remember what this is, because we'll see it often. Now 3 goes into 26 times. 6 times 3 is 18, with 2 left over, bring down the 0. And 3 goes into 26 more times, so we see this actually repeats. And we write that repeating 6 with a bar over top. Now 5/33, we're going to do 5 divided by 33. So the first number goes inside the clubhouse, and 33 is on the outside. And we rewrite that like $5. 33 goes into 50 times, it goes into 51 times. 50 minus 33 is going to end up being 17. Bring down a 0, and 33 goes into 170 5 times. And 30, 60, 90, 120, 150. So we see 5 times, and 5 times 33 ends up being 165, with 5 left over. And when I bring down that other 0, I see that I'm going to start this again. I'm going to get another 1, and then I'm going to get another 5 after that. So I see that it's going to go 1, 5, 1, 5, 1, 5. So both of these numbers are repeating. If they're both repeating, they both get the bar over it. Now we are going to convert from decimals to fractions. So when we're using place value to convert to a fraction, and then we are simplifying. We're going to write 1 under the decimal and a 0 to the right underneath each number, and this will become your denominator. The original number is your numerator, and this only works for terminating decimals. For repeating decimals, you only place a 9. 8 is in the tenths place, and we are going to write 8/10, and the decimal's not there anymore. It's kind of replaced by the fraction bar, and we're going to simplify by 2 to get 4/5. We have 25 in the hundredths place, so we have 25 hundredths. Biggest number I could divide by is 25, but if I divide by 5, I get 5 on the top, 20 on the bottom, and I can divide by 5 again. But you need to start recognizing which numbers are quarters, and we get 1/4. So here I have 5 in the hundredths place, and we are going to put 5 in the hundredths place, dividing the top and bottom by 5, and I get 1/20. For this next one, we have 3 decimal places, so it goes all the way out to the thousandths place. But we've got this 4 that's on the other side of the decimal. That's going to stay to the left, and that's going to be our whole number. So we have 4 as our whole number, 16 as our numerator, and 1,000 as our denominator. I noticed that I could divide the top and bottom by 4. I could have divided by 2, but I saw a bigger number. And 16 divided by 4 is 4, and 1,000 divided by 4 is 250. I see that I could divide by 2 again, so I need to keep simplifying. And 4 divided by 2 is 2, and 250 divided by 2 is 125. And I can't divide that or simplify that any further, so my final fractional or mixed number answer is 4 and 2 125ths. This next one, 0.125, is actually 125 thousandths. So we write 125 thousandths, and I know that I could divide the top and bottom by 25. So if I see a bigger number I could divide by, I want to start doing that. And 125 divided by 25 is 5, and 1,000 divided by 25 is 8, so 5/8 is our final equivalent fraction. Whenever we see the repeating bar, we do something special. So instead of a 10, we're going to get a 9. And 3/9 simplified will give me 1/3. This is the ones you should memorize. 7 is in the tenths place. So we have 7/10, but we have that 4 wholes as well. And I can't simplify it at all, so we just get 4 and 7/10. 2.46, we have 2 decimal places, so we're going to have the hundredths place. And we have 2 and 46 hundredths. I can divide the top and bottom by 2, and I end up getting 2 wholes and 23 hundredths. Sorry, 100 divided by 2 is 50. So 2 and 23 fiftieths. We're going to move from a decimal to a percent. So from a decimal to a percent, I'm moving 2 places to the right or towards the percent sign. And I'm going to skip over 2 numbers. So I'm moving towards the percent sign. The percent sign's always on the right side of a number. And if I want to turn it from a percent to a decimal, I'm getting away from the percent sign. So to get away from the percent sign, I need to move left. And I'll move left to skip over 2 numbers. So I want to think of 12 cents would give me 12%. So I move it 2 places to the right, and I get 12 cents, giving me 12%. This will always help you to estimate your answer. Now here, when I write money, it kind of gets cut off after the last 0 here. So I have 0.005, but it gets cut off here. So it kind of looks like 0 cents, but I move the decimal place to that cutoff point, and I have 0.5%. If I have 0.4, if I have an empty space, then I'm going to fill that empty space with a 0, unless the number's repeating. So that's the cutoff for cents, and I'm going to move the decimal to that cutoff point, and I get 40%. So 40 cents will look like 40%. 0.6 repeating, if I look at that, the next place value is going to be a 6 because of the repeating symbol. And that's going to be our cutoff, but we know that our 6 is going to keep repeating after that. So I'm going to move this 2 places to the right, and 66 cents will look like 66%. But we still have that 0.6 that keeps on repeating after the fact. And 66, and so 0.6 repeating is the same thing as 2/3, so 66.6 repeating percent is the same as 66 and 2/3%. We could have also written 0.5% as 1/2%. Now, if we have $1.62, cutoff is here, we're going to move it 2 places to the right towards the percent sign, and that's going to end up being 162%. That decimal disappears because it's after the 2. 0.368, we're going to cut it off at 36 cents, and that's going to end up being 36.8%. So we don't get rid of the 8, but it's kind of past the cutoff where we're going to be putting that decimal. Notice how we're always moving it to the right to move towards where the percent sign is supposed to be, because the percent sign is always going to be written on the right side of the number. So I'm turning it into a percent, I'm moving towards the percent, or moving 2 places to the right. Getting it away from being a percent sign, we have the decimal that's invisible here, and it becomes 0.78. So we're moving to the left to get away from being a percent. Then you need to get away from the percent sign. 9%. We're going to move it 2 places to the left, and if I have an empty space, then I'm going to fill that empty space with a 0. And I end up getting 0.09. And look at that, 9 cents will look like 9%. 120%, the decimal is hidden, and we're going to move 2 places to the left. Skip over the 0 and the 2. I skipped over 2 numbers, and I get 1.20, but I don't really have to write that last 0. So 1.2 is your final answer. Now 33 1/3, you need to remember that 1/3 is 0.3 repeating. So if I do this, I'm going to move it 2 places to the left, and I end up getting 0.33333, or 0.3 repeating. 0.9% already has a decimal. So I'm not going to start to the right of this number. I'm going to start where the actual decimal is. So if the decimal is hiding, you know it's to the right of the whole number. But if it's not hiding, you're going to start at where that decimal actually is. And if there's empty spaces, we'll fill them with zeros. So I have 0.009. And if that looks like less than 1 cent, then it should be less than 1%. Now we have 2.9%, so that's about 3%. It should be about 3 cents. So you're going to move it 2 places from where the decimal is starting, and we are going to put one placeholder of 0. So we have 0.02, which kind of looks like 2 cents. And if I round it up, it would be about 3 cents. Now we need to remember that 1/10 we'll put a 1 in the tenths place. So 1/10, 2/10, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. And we can also see some of these fifths. So if I simplify 2/10, I get 1/5, which equals 0.2. 4/10 simplifies to 2/5, which gives me 0.4, and 6/10 simplifies to 3/5, which is 0.6. 8/10 simplifies to 8/10 simplifies to 4/5, or 0.8. And we see that if we memorize the rule for the tenths, then we already memorized all the rules for the fifths. And if we divide the top and bottom by 5, 5/10 becomes 1/2. So we already know what 1/2 is as well. Now 0.1, I move it over, that looks like 10 cents, so it should be 10%. 20 cents, 20%. Then we count by tens, 30, 40, 50, 60, 70%, 80%, and 90%. Now the simplified ratio would be 1 to 10, 1 to 5, 3 to 10, 2 to 5, 1 to 2, 3 to 5, 7 to 10, 4 to 5, and 9 to 10. It's different for the ninths. You basically have the same thing as the tenths, the same pattern as the tenths, but you're putting a repeating bar over that. So if I simplify 3/9, I get 1/3, and simplify 6/9, I get 2/3. If I simplify 9/9, I get 1 whole. So if I remember the rule for the ninths, then I can remember the rule for the thirds as well. If I move it 2 places over to the right, I get 11, point that 1 that keeps repeating. If I double that, I get 22.2 repeating, 33.3 repeating, and I keep on adding 11.1 repeating percent, and I get all of the following percents. And since that actually equals 1, 9/9 actually ends up giving us 100%. So our simplified ratios are basically the same thing as our simplified fractions, but written with a colon. When you're talking about fourths or quarters, you need to remember that 4 quarters make $1, and 1 quarter would be 25 cents, 2 quarters would be 50 cents, 3 quarters would be 75 cents, and 4 quarters would be 100 cents. And we know 2/4 simplifies to 1/2, 4/4 simplifies to 1 whole, and all of the percents will follow with how many cents you have. And the simplified ratios would be like the simplified fractions. Now 2/4, we need to remember what numbers can multiply together to give us 100. This will help us in making percents. So if I try to go from a decimal to a percent, I need to move 2 places to the right and fill in any empty spots. So 0.6 would give me 60%. I'm going to fill in my empty spot here with 3's because it's repeating. So I could have 33.3 repeating percent. This seems to come up often. We should probably remember both of those. 0.75 ends up being 75% because I move it 2 decimal places to the right. Now let's try to change those same decimals to their fractional equivalents. So we have 0.6, and 6 is in the tenths place. So 6 is in the tenths place, and 6/10, if I divide the top and bottom by 2, will reduce to 3/5. So that is your simplified fraction answer. So 3/5 is equal to 0.6. Now 33.3 repeating, or 0.3 repeating, when I have a repeating symbol, I'm going to put the 3/9, so 3/9 simplifies to 1/3. 0.75 means that I have 75 in the hundredths place, and if I divide the top and bottom by 25, or I could think, 75 cents would be 3/4 of a dollar, 3/4. So the more you memorize, the easier some of these will be. If I move the decimal 2 places to the left, I would get 0.9. 2 places to the left, I would get 0.4. 2 places to the left, and I would get 0.25. And now that I change all those percents to a decimal by moving it away from the percent sign, I can change 9 to 9/10, which can't be simplified. 0.4 is the same as 4/10, so I could divide the top by 2 to get 2, divide the bottom by 2 to get 5. We could just see that 25 cents is equal to 1/4, or we could write 25 hundredths, divide the top and bottom by 25 to get 1/4, or 1/4. Now 6 divided by 6 is equal to 1 whole. So 1 is our decimal, and I can also write that as 1.00, or I can move that 2 places to the right to get 100%. So if I have 1 whole circle shaded in, it's 100%. So 3/10, I'm going to put a 3 in the tenths place. And for a percent, I'm going to move that decimal 2 places to the right to get my percent. 2/3, I can multiply the top and bottom by 3 to get 6/9, and I'm going to put a 6 in. I'm going to write 0.6, but that's going to be repeating because it's ninths. Now 0.6, if I move it 2 places to the right, I get about 66, but then I have that 6 that keeps on repeating on the decimal end. So I have 66.6 repeating percent, or 0.6 repeating is the same thing as 2/3. So I could replace that and write 66 2/3%. Now we're going to order and compare our fractions, decimals, and percents by changing them all to decimals. So if I divide 1/3 out, if I forget what that decimal is, then 3 goes into 1 0 times, and 3 goes into 10 3 times. 3 times 3 is 9, with 1 left over. Bring down the 0, and it starts all over again. So we see that that 3 keeps on repeating. So 1/3 is equal to 0.3 repeating. 62.5%, I'm going to move it 2 places away from the percent sign, and I'm going to get 0.625. 0.63 is just 0.63. 3/10, I'm going to have a 3 in the tenths place. So if I look at the 3 in the tenths place, or if I don't know how to do that, I could still divide. And 3 divided by 10, well, 10 goes into 3 0 times, but 10 is going to go into 30, so write the 3 like $3. 10 is going to go into 30 3 times with 0 left over. So that's another way we could have written 0.3 as being the equivalent decimal to 3/10. Now we're going to organize our numbers A, B, C, and D by lining up the decimals. So we are going to line up this all of the decimals for A, B, C, and D, and the more organized our work is, the more likely we are to get the correct answer. So we kind of make a little grid, and we're going to line up our decimals. So A has a 0 in the ones place, so I'm going to write a 0, and that 0 point, make the point pretty big, and we're going to line up all of the decimals here. So A is 0.3 repeating. So that 3 is actually going to repeat forever and ever. I'm just going to write 3 of those repeating digits and see if that's enough. B is 0.625. See how all my place values are lined up? My ones, my decimals, my tenths, my hundredths, and my thousandths. So we write C as 0.63, and then I don't have another number for that, so I'll put a 0. And D is 0.3, and I'm going to put 2 placeholder zeros. Now that we have our grid, we can look at the smallest numbers and compare those to the biggest numbers. So I'm going to look at the first column, and they're all zeros. So I'm going to go to the next column, and I'm going to look at 3, 6, 6, and 3. And I'm going to put those orders in order from smallest to biggest. So we're going to have the 3 and the 3 are kind of tied, and then we have a 6 and another 6 that are tied for the biggest. So we need to look at the 2 3s and see what the next 2 numbers are for those 2 that are tied. So next to the 3s, we're going to look at what the next number is for the 3s. We have a 3 and a 0. So 0 is the next smallest number, and 3 is the next smallest number. Then we need to look at the numbers that are tied with the 6s. So the 6s are tied in the tens place, and we're going to look at the hundredths place, and we see a 2 and a 3. So 6, 2, and then 6, 3 are next. And now we know exactly which number is going to be next. So 0.30 is the starting number for letter choice D. 0.33 matches letter choice A. 6, 2 matches B, and 6, 3 matches C. So if I look down here, ascending is from smallest to biggest, and descending is from biggest to smallest. So ascending, I'm going to go from smallest to biggest, and I would write D, A, B, C. So D, A, B, C are those fractions, decimals, and percents in ascending order. Now if I go the reverse way and go biggest to smallest, I would have C, B, A, D as my answers. We're going to write them in descending order. So for A, we're going to do 3 divided by 8, move the decimal place up, and 8 goes into 33 times with 6 left over, and 8 goes into 67 times with 4 left over, and 8 goes into 40 5 times with 0 left over. So A is 0.375. B, we move it over 2 places to left to get 0.38. C is already a decimal. And D, we should remember that I multiply by 25 and I would get a quarter. So 25 cents is equal to 1/4. Now if I list A, B, C, and D, making sure that we have everything in columns, the tenths places are lined up, the hundredths places are lined up, and the thousandths places are lined up, then we can start evaluating. So I have A, B, C, D, and I'm going to first look at the tenths place. You always move from left to right. So we want to go from descending order, so we're going to go from biggest to smallest, and we're going to focus on looking at the biggest numbers or the smallest numbers in the tenths place. So I'm going to order that, and I see that the smallest number is 2. It goes 2, 3, 3, and then 4. And the 3s are tied, so I kind of need to do a tiebreaker in the hundredths column and see that it goes 7 and then 8. So 2 is D, 3, 7 is A, 3, 8 is B, and 4 is C. So biggest to smallest is going to go from C, B, A, and then D. A, we already have a decimal, but B, if we do the 2 divided by 3 again, we see that B is 0.6 repeating. 3/10 for C, we can do the division for 3/10, or we could just put a 3 in the tenths place because we have this memorized by now. So having these memorized will help ordering them much easier. And we're going to move the decimal to the left 2 times to get 0.62. So A is 0.624, making sure we keep everything in columns. B is 0.666, repeating, and C is 0.3, and we'll put 2 zeros as placeholders, and D is 0.62, and we'll put a 0 as a placeholder. And we are going to kind of show or list them from smallest to biggest order, or increasing order. So I see that we can order 3, 6, 6, 6, and we've got a three-way tie. And we see our tiebreakers are 2, 6, and 2. So we know that 2 and 2 are the smallest and 6 is the biggest. And we have another tiebreaker, so now we need to go to the thousandths place for the 6 2's, and 0 comes before 4. So the 3 matches C, 620 is D, 624 is A, and 66 is B. So increasing order is smallest to biggest, so we're going to count smallest to biggest, and we go C, D, A, B. Write the letters of the following numbers in ascending order. Now 1/5 is 2/10 or 0.2, and now all of these are already decimals, and A is 1.5, B is 0.15, C is 0.2, and D is 0.33. Remember that when we're comparing, we need to keep all of our decimals on the same line and fill in zeros, or the repeating number, in all of the missing spaces. So if I'm going to look at the ones place, because I look at the biggest place value, or the place value most to the left, I see that we have 0, 0, 0, and then 1. So 1.5 is going to be the biggest. Now for the zeros, we need to do a tiebreaker in the hundredths place. So we have a 1, a 2, and a 3. So we have 0, 1, 0, 2, and 0, 3. So 0, 1, 2, and then 3. And we have that 1.5. So 0, 1 was B. 0, 2 matches C. 0, 3 matches D. And 1.5 matches A. So if I'm doing ascending order, it's smallest to biggest, and I'm going to go from the smallest to the biggest. We have B, C, D, A. Now for this next one, we're writing the letters in decreasing order, or they're getting smaller. A is 7.5. B, 8%, looks like 8 cents. 3/4, we should know by now that that's 75 cents. 3/4 is 75 cents. And D is already a decimal. So we're going to fill in those placeholders with zeros, and we are going to look at the ones place first. The smallest numbers are 0, and the biggest number is 7. So we have 0, 0, 0, 7. And we need to look at tiebreakers for the zeros, so we look at the tens place. We have 0, 0, 0, 3, and then 0, 7. That will be in that order. Now, 0, 0 is for answer choice B, and we can see 0, 3 is answer choice D, 0, 7 is C, and 7, 5 is A. So we're going smallest to biggest, or B, D, C, A. We need to remember that 3/4 is equal to 75 cents, which would be 0.75 as a decimal. So we can multiply both of these by 25 to get 75 hundredths, or 0.75. We can show 0.75 if I have 2 decimal places. I need 2 decimal places for this, so I'll put a 0 next to the 7. And 75 cents is greater than 70 cents. Here we're going to move the decimal place 2 places to the left to get 39 cents. And we see 2/5 is equal to 4/10. So 4/10 is equal to 0.4. And 39% is equal to 39 cents. But we want to make the 0.4 look like 40 cents. So 39 cents is actually less than 40 cents. 8/8 is equal to 1, and 99.9, we move it 2 places over to the left, and I get 0.999, and 1 whole is always going to be greater than any decimal.